Hello Math 130 students, let's pick up on page 4, section 9.2. We're going to be talking about parabolas as conics. So we've seen the parabola written in different ways. This new way is going to be called the vertex form, where we have the h and the k, which is the center, our vertex. And we also have that standard form where we have the ax squared plus bx plus c. So again, I'm just going to write over to the side that the vertex is given to you as an h and k value, and we do have our h and k. So for example, it says we're going to look at the function f of x, and we want to know whether or not the parabola opens upwards or downwards. So opens upwards, opens up. And the reason for this is because it's positive. That a value is greater than 0. If I have a parabola that looks like this is the way that it opens when it's downward. So this is a negative parabola. This is when our a value is less than 0. So notice how we have an a value. So if it's positive, then we know it's a happy positive parabola. And if it's a negative, then it's a sad frowning parabola. So whether it opens upwards or downwards, it's really going to be represented by this a value. So here our a is equal to 2. That's a positive. So that means it's going to open upward. Okay, now it specifically wants us to find the vertex of the parabola. So to find the vertex, I know that's here and here. That would be my h and my k value, so that the vertex is going to be a positive 3 and a negative 4 for your h and k value. Okay, so then if you are determining the equation of the axis of symmetry, well, that's x is equal to, and it's always going to equal this h value, so it's going to equal to 3. So x is equal to 3 is the equation of the axis of symmetry. Now it wants me to graph this parabola. Well, at the very least, I know that I have 3, negative 4. And so if I have some x and y values that I can plug into this equation, well, at the very least, I know I have 3 and negative 4. So if I have y is equal to 2, x minus 3 squared minus 4, well, let's plug some values in. Let's try x is equal to 2 and x is equal to 4. Well, when you plug it into your equation, into your calculator, you have 2 on the outside, and you're plugging in a 2 for x minus 3 inside parentheses squared minus 4. Well, that gives you that your y value is equal to a negative 2. And if you are going to try that x is equal to a positive 4, well, you would have 2 on the outside, parentheses, 4 minus 3 inside parentheses squared minus 4, and you get a y is equal to negative 2. So 4, negative 2 is here, and 2, negative, oops, and I didn't write that point down. Let's zoom in a little bit better. So it was 4, negative 2, and it was 2, negative 2. So that my parabola more or less looks like this when I graph it. Now, for example number 2, it's written in the form that I have y is equal to ax squared plus bx plus c. So this is in standard form. It is not written in vertex form. So whether it opens upwards or downwards depends on the a value. So here my a's value is -2, so it's going to be downward since it's negative, okay? Now to determine the vertex, here I'm going to have to plug it into the equation. I know that the h value of my vertex can be calculated as -b over 2a. So I know that my b value is a -8 and my c value is a -6. So the b value that I'm plugging in is a -8 and the a value is a -2. So I'm going to get that my h is equal to a +8 over a -4. So 8 divided by -4 is going to give me a -2. So I know that for my vertex, that h value, I have a -2. Now to figure out that k value, I plug it in. So since I have that h is equal to -2, I'm going to plug it into the equation. So that y is equal to -2 x squared minus 8x minus 6. So this is going to give me my y, or my k value. So I have a -2 on the outside, -2 on the inside of the parentheses squared, minus 8 parentheses -2 minus 6, which gives me a +2. So this tells me that the k value is equal to a +2. And so to determine the axis of the symmetry, well, that's just going to be x is equal to, and it's always going to equal to this h value, so -2. So when I graph this, I have my vertex of -2, 2. I know that this is a downward facing parabola. And now I have the equation y is equal to a -2x squared minus 8x minus 6. And that vertex that I found was that -2, 2. If I plug in a 0 into this equation, right, 0, 0, I get back a -6. So 0, -6 is here. So I'm going to see what happens at +2. Well, I would have a -2 squared minus 8 minus 6. And that value that I'm plugging in now is going to be a +2. So plugging that into my calculator. That gives me a -30. And I see what I did wrong here. 0, -6. That means the x is 0 and the y value is a -6. There we go. That's going to be a lot better. So make sure you graph that point correctly. I went too fast and furious. I still got my 2 -30, but now let's try what happens at -4. So I can keep plugging into my equation. And that value that I want to plug in now is a -4. So if I have -2 inside my parentheses, -4 squared minus 8 times a -4 minus 6 gives me a -6. So now I have my graph, more or less. Okay. So that's my graph, and I had to work a little bit for those points, and I had to make sure that I graphed the points correctly. Slow down if you think you're going too fast and making mistakes. That's what happened to me. Page 6, we now revisited parabolas that go up and down, and now we have parabolas that go to the right and parabolas that go to the left. Okay, And so that vertex form, what's really, really different about it is that I have x equals instead of y equals, right? Okay, so that's kind of interesting. So here I would normally have that y is equal to ax squared plus bx plus c. But now that it's opening to the left and right, I would have an x is equal to an ay squared plus a by plus c. And that's what we have in equation number 1. And we want to graph the following. So here, if we're just graphing, we can just find some points to help us out. So what might be easy to plug in is my y values first. So let's say that my y value here is going to equal to 0. So then I would have 3 times 0 squared minus 6 times my 0 plus 5. Well, that would just give me 5. So I have this 5 comma 0 as my ordered pair. So now let's try a different value. So maybe instead of 0, we are going to try a 1 in there instead. So I'm going to have a 1 inside the parentheses. So it'd be 3 times my 1 squared minus 6 times 1 plus 5. And that's going to give me a positive 2. So now I have a 2 comma 1 as my ordered pair. So we're going to just keep plugging in some more values. So I don't know, let's try that my y value is equal to a negative 1. So I have 3 squared minus 6 plus 5. So what I'm plugging in is a negative 1. So 3 times my negative 1 squared minus 6 times negative 1 plus 5 gives me a 14. So I have a negative 1 and a positive 14 that I get out. So that seems to me very high. So now let's see what happens when I plug in a positive 2. So if I were to plug in a positive 2, well then I would get 3 times 2 squared minus 6 times 2 plus 5, which is a 5. So now I feel a little bit better about the answers that I got. So I have a 5, 0. Oops, got some points there. Okay, so let's try that again. So I have a 5, 0. I have a 2, 1. I have a 14, negative 1, so that's like down here, right? And I have a 5, and it's a positive 2. So it looks like more or less my graph is doing something like this. So it's opening up to the right. So all I did was plug in some values to kind of help me figure out how to graph this thing. For the second problem, it's a little bit different because I already have my h and my k value. So notice that here I still have my x equals, right? So that's okay. And I have my h and my k value. So my vertex is given to me as a 2, 3. And I also know my a value. So a is equal to a negative 3. Since a is equal to a negative 3, I know it's opening up to the left. So I have my vertex as 2, 3. And it's opening up to the left. And so to the left means this way, to the left, right? But I want to know exactly or at least get really close to what my x and my y's are going to be. So I already know I have the ordered pair 2, 3. So let's try something else. Let's try to plug in a positive 1 for y. So I get x is equal to a negative 3, 1 minus 3 squared plus 2. So negative 3, parentheses, 1 minus 3 squared plus 2, and get a negative 10. So I have a negative 10 and a positive 1. Okay. So that's what happens when I get a positive 1 there. So let's see what happens when I plug in, let's say, a negative 2 in for my y value. So for that y value, let's plug in a negative 2 and see what happens. When I plug in a negative 2, I get something like a negative 73. So that's way off the charts. So now I'm like, okay, well, let's think about this. If I have a negative 10 and a positive 1, that is going to be over here. Okay, so my graph more or less looks something like this. Okay. So I don't really need to find that third point, I guess, since I know it's symmetric, right, because of the axis of symmetry. So I was having a little bit of trouble finding my x and y values, so I just dealt with 2 values, and that's perfectly fine to do. Okay, and that is the end of this section. So just try to find good values to plug in.